Good day everyone. Again, I am Teacher Decker and our topic for today is all about the atoms, molecules, and ions. So at the end of this lesson, you are able to explain how the basic laws of matter led to the information of Dalton's atomic theory. So describes Dalton's atomic theory, differentiate atomic number or average atomic number, and then explain relative atomic mass or selected isotope. Then write isotope notation, recognize common isotope, and their uses. Then differentiate among atoms, molecules, ions, and give examples. And then represent compound using chemical formulas, structural formulas, and models. And then give the similarities and differences between the empirical formula and the molecular formula of a compound. Name compounds given their formulas and write the formulas of the compounds given their names and practice name ionic compound and writing their chemical formulas. So now, for the birth of atomic theory, so during the 4th century BCE, a Greek philosopher named Democritus had the idea that all matters considered of minute particles, so which he then coined atomos. So he could not provide a factual basis to his claims because atomos was purely based on philosophical reasoning. So Democritus um, claimed that the atoms are purely based. And then the second person who studied the theory of atom is the John Dalton. So during the time of John Dalton, okay, during the 19th century, so the John Dalton formulated the atomic theory. So an element is made up of extremely small indestructible particles called atom. So atom of the same elements shared the same chemical properties. Then atoms of different elements have different chemical properties. Compounds are made up of atoms of more than one types of element. So the ratio of the number of atoms of any two elements presents in either an integer or a simpler fraction. So in any chemical reaction, atoms are rearranged to produce different substances. And then the three fundamental laws of matter. The first is the law of definite proportion or constant composition. So in this first law of atom states that or explain that the elements combine in ratio or of a simple whole numbers to form a compound. If you will get samples water or H2O from the different areas and the subject these samples of chemical analysis. So you will find that the molecules of water regardless of this source. So always composed of two atoms of water and one atoms of oxygen. So these are the experiments that shows of the law of definite proportion. So these are the periodic table that shows the metals, non-metals, and metalloids. So now, next is the law of multiple proportion. So in law of multiple proportion explains that when two elements react to form two or more different compounds with one fixed or constant element, the mass ratio of the constant element is the compound is expressed in the smallest whole number. And then, thus the different compounds with the same or fixed elements with differ in the number of their atoms. For example, we have the carbon dioxide and carbon monoxide. So, are two compounds primarily comprising C and O. So, though both compounds are constituted by the same type of elements, they behave differently because they are composed of different number of atoms on the elements. Okay? And then the third law is the law of conservation. So, law of conservation explains that the amount of the reactant is always equal to the amount of the product in any reaction. So this restatement of postulate of Dalton's atomic theory. So this law states that any chemical reactions, atoms are always conserved. So no atoms will be destroyed or automatically created. So they are just undergo forming a new substance, but new numbers of atoms are still intact before and after any reaction. So this paved way for the rapid progress of chemistry during 19th century. So now, let us move to number and mass number of the atom. So atom, it contains a nucleus composed of protons, neutrons moving around the nucleus. Then atomic number is equal to the number of protons in an atom. So the atomic numbers is also equal to the number of electrons in the same atom. So mass number is the total amount of particles, numbers of protons and neutrons. So again po, mass number is the total amount of particles of protons and neutrons. So found in the nucleus of an atom. So again po, as you can see, the letter A here is the mass number. So we need to get the sum of proton and neutron in able to compute the mass number of the elements. So for example, how many neutrons are there in atom of 2412 Mg? So the mass number is 24, the atomic number is 12. So you are going to get the mass number or atomic number. In getting the number of neutrons, you need to subtract the mass number to atomic number. So 24 minus 12 is equals to 12. And then for another example, how many neutrons are there in one atom of 82 lead? So, yan po. So, the mass number is 207. The atomic number is 82. So, for the number of neutrons present in lead is 125. And then, for the structure of atom, so atom is the basic unit of elements that can take part in the chemical reaction. So, for the structure of an atom, so first is the electrons. So, electrons is the negatively charged subatomic particles with the mass of 9.11 times 10 raised to negative 28 gram. So, it has discovered by J.J. Thomson in 1856-1940 using the cathode ray tube experiment. So, as you can see in the picture, so he noticed that the ray produced at the negative electrode or the cathode ray was repelled by the negative pole of an existing electric field when high voltage was applied to a vacuum tube. So based on this observation, he suggested the cathode ray has made up of stream of negatively particles from atoms called electrons. And then next is the proton. So proton is the positively charged subatomic particles with a mass of 1.6726 times 10 raised to negative 24 gram. So it is located at the center of a top atom called the nucleus. So it was discovered by Ernest Rutherford in 1871 in 1931. So using his famous Gold-4 experiment. So the Ernest Rutherford observations are the following. So most alpha particles particles pass through the Gold-4 without deflection. So few alpha particles were strongly deflected. So some alpha particles slightly deflected to more than 90 degrees. So based on this observation, he concluded that the atom is mostly empty space with the small solid positively charged nucleus. So an atom of an element is mainly characterized by the number of protons. Okay? So next is the neutron. So neutron is the electrically neutral subatomic particles with a mass of 1.6749 times 10 raised to negative 24 grams. So it was discovered by James Chadwick. So in 1891, in 1974, using his beryllium foil experiment. Okay? And then, in this beryllium foil experiment, he observed that there was a less deflection of particles, implying the existence of neutral particles or particles in the nucleus together with protons. So thus, the mass of the protons and neutrons account to for the atomic mass. So again, this is the table or the summary of subatomic particles and their properties. And then now, we have moved to the history of the structure of the atom. So first, we have the Dalton proposed the invisible unit of an element is the in the atom. Then the second is the Thomson. So he discovers the electron. So he believed that resides within the sphere of uniform positively charged. This a model is called a plum pudding model. And then for Rutherford, he demonstrates the existence of positively charged nucleus that contains nearly all the mass of an atom. And then the Bohr's proposed fixed circular orbits around the nucleus for electrons in 1913. And then in 1926, in the current models of the atom, electrons occupy the regions of the space orbitals around the nucleus determined by their energies. And then these are the atomic structure of oxygen with isotope. And then isotope can be classified as stable or unstable. So a stable isotope are isotopes that do not undergo radioactivity and do not distinguish. So and then while unstable isotope is isotopes that are those exhibit radioactivity. They can be natural or artificial. So these are the examples of isotope. Yan. And then the different uses. So in relative atomic mass, there is a difference among the mass number and then atomic weight number. So in relative atomic mass, the mass is based on the sum of the protons and neutrons in an atom. So it does express the whole numbers. And then atomic mass, atomic weight, or relative atomic mass is the periodic table is this the consolidated average of the masses of the naturally existing isotopes relatively to the mass of carbon-12. So, in computing the relative atomic mass, we are going to use the summation of mass of the isotope times the percent abundance of an element. So, the examples of isotopes. So, chlorine has 2 isotopes here. So, for example, we have the titanium has 5 common isotopes for 46, which is the 8%, and then 47, which is the 7.8%, and 48, 73.4%, and then 49 with 5.5%, and 550 we have the 5.3%. So what is the average isotope? So now, when an atom lose or gain electrons become stable when we form ionic bonds. So electron transfer produces an imbalance in the charge of atom that results in formation of ion. So when an atom gains an electron, it becomes negatively charged and it then could an ion. So when an atom gives up electrons, gives up an electron exchange becomes positively or positive. That is called the cation. So molecules of atoms combined with establish that themselves become their either lack of exceed and required number of electrons for stability. So a collection of 2 or more atoms held in a specific arrangement due to sharing of electrons and acts as this single unit called molecule. So the atomic molecule is the combination of the same element. So now let us continue our discussion for my next lesson. So, okay.